Okay, we are back and better than ever. We're working on section 4.3, writing a polynomial function from its roots. And a couple things I want to do before I move on to the new stuff. I want you guys to recall 4.1 when we graph polynomials from its equations. So we had equations that kind of look like this, and we can very well put it in standard form, right? We can do a box for the x minus 2 squared, which would be x squared minus 4x plus 4, and then we can multiply that by x plus 1 and do another box there, 2 by 3, and multiply through. Not necessarily worried about that right now. But what I am worried about is some different things called zeros. Remember, zeros were where the function, the graph, crossed the x-axis, right? They're called solutions, roots, x-intercepts, and also zeros. So this here, the x plus 1, our 0 is 1, and then this one here is 2. Okay, we're going to talk about this here. I don't remember if we talked about it before, but it's called multiplicities. We'll get more into it today with this video here. So what this means is, I'm sorry, this is actually -1, is that that's where one of the graph crosses the x-axis right here, and it crosses here at 2. Because this is a multiplicity of 2, we'll again talk about what that means. That means at that point, the graph is either going to make kind of a U or an upside down U at that particular point. And if I were to actually graph this, I'm not going to use a calculator or whatever, I just want a generic graph. It's going to look something like that. Okay, again, it's not perfect, but you get the drift. This should actually cross right there, but that's fine. You see right here, it creates a U right at that point, and that's what should happen there. Don't care about that right now. But that's what we're going to be using. Okay, we're going to be using this information here, and now we're going to go backwards. So I'm going to be given the zeros, and we're going to go backwards into writing it in standard form, that particular way. So let's get started. Okay, so while we're discussing this new material here, there are 3 different types of roots that we'll be discussing. Our first root is what we call a rational root. Okay, so rational roots contain integers, there we go. They also contain, they could contain potentially fractions. I don't think we're going to have any of that, but they could. They contain anything that can be written as a fraction. Okay, the second one is going to contain irrational roots. Irrational, there we go. Irrational roots, and they contain square roots. Okay, so they contain square roots. So anytime you see a square root, that means it's an irrational root, and that means it's kind of a little bit different stuff to work on. The third and final is we're going to work on imaginary roots. And remember, imaginary stands for the letter I. So they contain the letter I. And remember, I stands for the square root of -1. We don't necessarily care about this right now. We do care about that letter I, and we'll again get to those particular problems as well. So let's get into some examples with some rational roots. Okay, so these are rational. We'll go in different sections here so we can see kind of the similarities, the differences between all of them, and then we'll tie it together at the end and see what we come up with. So I got some steps here. We'll talk about these steps as we go. You guys can take a look at this as well. So write a polynomial function of least degree with integral coefficients. Integral, again, means we just want positive or negative numbers as coefficients. We don't want fractions with the given zeros. So these are zeros. Okay, these are the zeros of the function. So if you were to graph this function, this equation with these zeros, you would get 4 times it would cross the x-axis. Okay, it would cross at 0, 5, -4, and -5. And what we want to do is write the equation of what these functions, these zeros actually come up with. All right, here's how we do that. What we want to do is we want to take these zeros and we want to go backwards into parentheses. Okay, so we want to take the roots. First step is take the roots and write them as a binomial or a trinomial. Right now we're going to be dealing with the binomials. Trinomials will come in the irrational and imaginary roots, but they're there for that reason. So here's what I mean. This 0 is actually written as x plus 0. Remember, this 5, when it goes into a binomial, it's actually the opposite. And then the -4 is actually the opposite. Okay, and then the -5 is the opposite. So you can easily see that this is where we did in 4.1, and actually previously before as well, with quadratics, and we solved it this way, is we went backwards. We took the opposite numbers out of the parentheses in that way. So some of you might be asking, why is there an x plus 0 here? Well, remember, x plus 0 is just an x. When we have x by itself, remember, our 0 is just 0 because it's a monomial. Any monomial is always 0. So then I have the x minus 5 still, the x plus 4, and the x plus 5. Okay, so that's the first step. Second step is multiply the easy ones first. Easy? These aren't easy. What is this? What does that mean? This means that the easy ones are going to be the x minus 5 and the x plus 5. You can see that they're pretty similar binomials. One's a positive, one's a negative. And those are the easy ones. We're going to do those first. Because if I take x minus 5 and x plus 5 and I multiply it together, I actually get x squared minus 25. I can do that right in my head. The middle terms cancel. Okay, so x times x is x squared. Negative 5 times 5 is 25 with the minus there. So that's the easy one. That's why I'm saying do the easy ones first because it just makes more sense that way. Then I have the x times x plus 4. I didn't touch those. Remember, those are from over here. And then the x squared minus 25. So I'm going to distribute through. That's x squared plus 4x. That is now being multiplied by x squared minus 25. Well, guess what? I have two binomials now, and I can make a box. Okay, so I get, say, x squared up here, 4x over here, x squared minus 25, and I get x to the 4, I get 4x to the 3, I get negative 25x squared, and this one is negative 100x. Now let's pop things out. If I pop out, what do I get? I get x to the 4. Okay, that's step 3, right? Remember, we finished the multiplication. Step 3. Then I get plus 4x to the 3rd minus 25x squared minus 100x. You notice the diagonals in this one didn't actually combine because one's a 3, one's a 2. The degrees are different. Then step 4 is write it as p of x or f of x. So this is your answer with p of x in front. Now p stands for polynomial. So polynomial of x, x is the variable that we're using. You are very capable of using f of x equals, and then that as well. F just stands for the function of x. So p is polynomial, f is function. Doesn't necessarily matter which way you write it, but you do need this in front. You need it there. Okay? So that's the first example. Let's go to number 2 there. So number 2, again, I want to take the roots and write them as a binomial. So we get x plus 2, we get x minus 4, x minus 1, and x minus 3. Second one says multiply the easy ones first. There's really no easy ones here. None of these are kind of similar. This is a positive, a negative 4, a negative 1, negative 3. None of them go together. So what I'm going to do is I'm going to take the first 2 here, multiply them through. X plus 2 and x minus 4. You can do a box. I'm not going to. I'm just going to do it real quick in my head. So that is x squared minus 2x minus 8. Okay, you can very easily do that in your head. If you can't do FOIL, box, or distributor property, it doesn't really matter. Then what I'm going to do is I'm going to do the second 2 terms. Again, x minus 1, x minus 3. I'm going to do that in my head as well just because I don't want to take up space with boxes. So that's x squared minus 4x plus 3. Okay, again, now I have 2 trinomials, and from the last section you knew how to multiply these together. So I get x squared minus 2x minus 8. I get x squared minus 4x plus 3. And now I have my 3 by 3 box, just like I did in the last section. So we're going to go through this quickly here, and then we'll come back with an answer.
Pause the video.
So here we are with the answer. We got p of x is equal to x to the 4 minus 6x to the 3rd plus 3x squared plus 26x minus 24. You can see the diagonals in this one actually did work. You can combine those. So again, if you need help multiplying a 3 by 3 box, go to the last section, 4.2, and work on that. But I'm going to kind of skip those steps here, make them a little bit quicker. So let's go on to the last question here for this particular example of rational roots. All right, now, we talked a little bit about multiplicities up at the top, but we didn't really get into all the great detail of it. So it says negative 2 multiplicity of 2. So I'm going to take the negative 2 here, and I'm going to put that into my binomial, which is still x plus 2, the same as what we did up here. Multiplicity of 2 just means I have 2 of them. Okay, 2 is my exponent on the whole binomial. Then I have this x minus 3 here. Okay, so then the second step says multiply the easy ones. Well, guess what? This is an easy one. If you can't do that in your head, again, you can do a box or, FOIL or distribute. But that should be easily done in your head. That's x squared plus 4x plus 4. Okay, that's now become a trinomial times x minus 3 as our binomial. And I'm going to multiply it out. I'm not going to do the box. I'm just going to write the answer down. But take your time to multiply that out and see if your answer matches mine. Okay, your answer is p of x is equal to x to the third plus x squared minus 8x minus 12. That's your answer for number 3 there. If you multiply these two nomials together, one's a bi and one's a tri, you should have gotten this. If you needed to use a box, again, go ahead and do it. But this is what your answer is. So if you need help, again, go back to 4-2. Okay, now this is where it gets a little tricky. Okay, we're going to kind of move on to the next section. Remember, the last two roots that we're dealing with were imaginary and irrational. So with those imaginary and irrational roots, we have some theorems that we have to kind of understand and what they mean. So the irrational root theorem, we have 2 of them. They basically go hand in hand, but there's 2 different theorems that you need to know. So the irrational root theorem, what that means is that if I have an irrational root, okay, remember irrational roots contain square roots. Okay, so I will say square root of 2 is just an irrational root. It could be square root of 58. It could be 1 plus the square root of 7. Okay, it doesn't really matter. So let's do that one. 1 plus the square root of 7 is also irrational because it has a square root in there. So if I have an irrational root, that means this theorem states that the conjugate is also a root. Okay, the conjugate is also a root. We'll get into more what that means, but that's what the theorem states. I'm not going to go into proving it and all that stuff. You can go look it online if you really want to be more interested with that. The complex root theorem states basically the same thing. It says if I have an imaginary root, okay, remember complex roots are i's, imaginary are also i's. So if I have an imaginary root, the letter I, or say 1 plus 3i, those are imaginary roots because they contain the letter i's, then the conjugate is also a root. Now, conjugates, what the heck is that? Conjugates, we actually did a little bit of conjugates before. We didn't really go into great detail with them, but we did a little bit. Conjugates are just saying that I take the opposite. So this is the square root of 2 up here. That means the conjugate is negative square root of 2. All we're doing is going to where the square root is and changing the sign in front of it. So this is 1 plus the square root of 7. The conjugate is 1 minus the square root of 7. That's the conjugate. So this one here, this is I. The conjugate is negative I. 1 plus 3i, 1 minus 3i. Again, we go to just the imaginary or irrational part and change the number in front. So let's go to some examples here. This is not irrational or imaginary. So that means that that's the rational. Remember, we talked about in the previous 3 problems. This one doesn't have an opposite root. We didn't have any opposites on the one above, so this one stays the same. This is imaginary and this is imaginary. So I need to find the additional zeros. Because of the roots, it says I have the opposite as well, the conjugate of this. Well, what's the conjugate of a negative I? That's a positive I. Remember, we take the sign in front and we change it. So this one is also imaginary because of the I here. So I'm going to take everything, and the only thing I'm going to flip is the sign in front of the imaginary part. That's it. That's all you're doing. It's just find the additional zeros. We're finding the additional zeros. This one here, oh, this is a positive I, so that's a negative I. This one here is negative 1 minus 2i. Well, this one here is negative 1 plus 2i. Isn't the negative the opposite is then positive? And they're exactly the same otherwise? So the opposite of this one is already here. So I don't need another one because it's already there. So this is the only one that I need right there, is that negative I. And then number 6, now I have imaginary and irrational because of the root. So what's the conjugate of 2 minus 2i? 2 plus 2i. Then 2 plus root 10, 2 minus root 10. Again, you go to just the imaginary or complex part and change the sign in front. Positive to negative, negative to positive. Everything else stays the same. You notice the 2's stay the same, the 2's stayed the same. Everything else stays the same. Don't get confused with changing everything. Just change the sign in front of the imaginary or irrational root. Okay, so that was our kind of notes and understanding of that. Now let's get into some examples of how we kind of use this information. Okay, we're going to use those same steps from before with writing a polynomial function from its roots. We had 4 of them. I don't have them here because we need as much room as we can possibly get. So you can refer to them on your notes as well. So what I'm going to do first is I'm going to write them into binomials or trinomials. All right, so I have, this is x plus 3. That's the same as before. And this one here, if we look at it, is x minus root 10. Okay, the opposite. Positive 10, positive root 10, negative root 10. Same thing we did here, opposite. But from the last 3 examples, or 4 examples, whatever we just did, we have to identify the opposite root, the opposite 0 here, right? So it's root 10, so that means we have a negative root 10 because of the irrational root theorem. I have both roots as roots. So that means that I now have x plus root 10. So I went from a 2-root question now to a 3-root question. So that means I'm going to have x to the 3rd somewhere in my answer, okay, because I have 3 x's now, right? Now the second step is multiply the easy ones first. Well, these are the easy ones here because they are opposites of one another. Go always, 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 always do the opposites of irrational or imaginary roots first. Negative root 10, positive root 10, always do these first because these are really, really easy to do. So when I multiply these two, I get x squared minus 10. What? Some of you might be asking, how do I do that? Well, if I take x minus root 10 and then x and then positive root 10 there, this is x squared, this is x root 10, this is negative x root 10, and this is negative root 100. Well, what's the square root of 100? That's just negative 10. And if I look at the diagonals, oh my gosh, they cancel. Holy cow. So that's why I get x squared minus 10. So that's very easy and very fast to do. Please do that in your head if you can. It just saves a lot of time. Okay? So I have x squared minus 10 times x plus 3. Now I'm going to multiply that. So use it on a box here. We get x3, x squared, negative 10, x to the 3, 3x squared. We get negative 10x and then negative 30. And I can write it out as x to the 3rd plus 3x squared minus 10x minus 30. Remember, with p of x out front, or f of x, whatever you want to use. But this is our answer for number 7. Okay, let's go to number 8. Number 8 says that if I have negative 2i and then negative 2 plus 3i, I can write these in parentheses, okay, into my binomials or trinomials. But remember from the irrational and imaginary root theorems that I have the opposites as well. So this is negative 2i, so the opposite is 2i. This is negative 2 plus 3i, so the opposite is negative 2 minus 3i. Okay, so now I have 4 roots, not 2 anymore. Now let's put them in parentheses. X plus 2i, x minus 2i. Okay, so the opposite of negative 2i is positive right here. Opposite of positive is negative. So I have my 2 roots for my 2 i's. Now let's deal with these because these are going to be a little bit tricky. So here we go with these. We have x. Now, I'm taking the opposite of these, right, when I put them in. So I got to take the opposite of these. And when I take the opposite of these, everything becomes the opposite. I don't want to go into the full rationale behind it, but I will if we need to in class or whatever, if we have more questions. The reason behind that is I just take the opposite. Okay, so it's positive 2 minus 3i and a positive 2 plus 3i. So now these two, this one became this one, and this one popped over there. So now that's what I have. So now I have 4 roots written as bis or trinomials. And now let's multiply through. Let's multiply these ones first because those are easy. That gives me x squared plus 4. Plus 4, you ask? Well, remember that it's, I'm just going to do it real quick. So this is x squared when you do a 2 by 2 box, right? And this is negative 4i squared. This last box here, negative 4i squared. Well, what is I squared? I squared is negative 1. So I really have negative 4 times negative 1, which gives me a positive 4, which is what I get there. Oh, man! Yeah, hopefully we learned something a little bit. X squared plus 4. Then I'm going to do these 2 trinomials here as a box. And I'll kind of go through some shortcuts that you guys can kind of use. So I got x2 negative 3i, x2 positive 3i. Now, here is some shortcuts. When I'm multiplying by trinomials here, whether it even be i's or with roots, we can have roots, and we'll get to roots down here and down here as well on number 10 and 9 and so on. But what happens is, when I have a 3 by 3 box, these squares, they're going to cancel. Okay? Just like in my 2 by 2 box, these squares here cancel because the opposites are going to cancel. Okay, so these 2 squares here and these 2 squares here, they actually cancel. So you don't actually have to multiply anything in those as well. So I get x squared, I get 2x, I get 2x, I get 4. Now down here, I get negative 9i squared, which is actually equal to positive 9. So then I get x squared, 2 and 2 is 4x, and then 4 plus 9 is 13. Okay, I can combine those 4, 9, 13. Now let's multiply those together as x squared plus 4. And you can do this box, so do the box here, plus press play when you have this done, and you'll see if your answer is right. And if you multiply that through, you should get x to the 4 plus 4x to the 3 plus 17x squared plus 16x plus 52. So this is your answer to number 8. Okay, so that's your answer. You multiply through and you get this. All right, let's go to number 9 here. Let's go to number 9. Number 9. All right, again, I want to make sure I have all the opposite roots or conjugate roots that I need. If I look at the square root of 6, isn't my conjugate root negative square root of 6? So I already have both of them. I don't need to write another one. But 1 plus 2i, another one is 1 minus 2i. So now how many roots do I have? 1, 2, 3, 4, 5. So somewhere I need an x to the 5th in there. Okay, x to the 5th is somewhere in my answer. So let's see what happens. We got to take the opposites, right? So this is actually x plus 5 opposite, x minus root 6 opposite, x plus root 6 opposite. Now we have x minus 1 minus 2i. Remember, everything is opposite. And then x minus 1 plus 2i. Again, everything is opposite. You notice my 1s, they're opposites. Okay, my 2i's, opposite negative 2i. Negative 2i, opposite positive 2i. Okay, you have to do that. Otherwise, your answer is going to be, you're going to have negatives when it should be positives, or smaller numbers when it should be bigger numbers. Got to watch out for that. Now let's multiply easy ones. X minus square root of 6, x plus square root of 6, x squared minus 6. If you need help, use calculators. You can do a box, I don't care, but I'm not going to spend the time on doing that. Now x minus 1 minus 2i, x minus 1 plus 2i. You can do a box. Remember, 3 by 3 box. Remember I said 3 by 3 boxes. These squares don't actually matter. And then these squares here are going to add. And then these squares here are going to add. So you can fill in your boxes for that, multiply that through, and see what you get. I'm going to tell you what I get. I get x squared minus 2x, and then plus 5. Okay, so remember, this again should be your x squared. This should be your negative x, negative x. This was a positive 1, and this would have been a positive 4. So that's how you get that. Okay, then I have the x plus 5 still there, with the x squared minus 6 still there, with the x squared minus 2x plus 5 there. So now I have two binomials and a trinomial, and you have to multiply them together. Okay, so multiply using your boxes, and then press play for the answer. And after you multiply these boxes, so multiply these, you get another trinomial. Trinomial times a trinomial. You should get your answer as, actually this could be a polynomial, right? It might be 4 actual terms, I believe it is. So your answer is going to be p of x, or f of x, doesn't matter. X to the 5th, remember we need the x to the 5th in there because I have 5 of them up here, so that needs to be a 5, plus 3x to the 4 minus 11x to the 3 plus 7x squared plus 30x, and then minus 150. So this is your answer for number 9. For number 9. For number 9. Number 9. So there you go. Okay, again, if you need help multiplying bis and trinomials, go back to 4.2. I'm not going to spend much time on that because you reached this point, so you are successful on 4.2. So let's go to number 10 here. Number 10 is going to be a little bit tricky, so let's kind of get started. So remember, -5 multiplicity of 2, what does that mean? That means that I have an x plus 5, remember opposite to the 2 power. Multiplicity of 2 just means I have 2 of them. And then this, because this is an irrational root, okay, it's got a square root there, I need the opposite, so it's, it's -2 root 2. So the opposite of 2 root 2 is -2 root 2. So now let's put them in parentheses. X minus 2 root 2, that's what that is there. And then x plus 2 root 2, and that's what that is there. Okay, opposites, opposites. Now let's multiply the easy ones first. Well, guess what? These are easy here. That's x squared plus 10x plus 25. Okay, that's what that gives you. And then this one here, if you don't remember how to multiply with the square root but with a number outside the coefficient of it, I'm just going to kind of give you a little bit of a refresher. So x minus 2 root 2, 2 root 2, and then x plus 2 root 2. So because they're opposites, one's a positive, one's a negative, that means the middle is going to cancel. That means I can just do x times x is x squared. 2 root 2 times 2 root 2, okay, so 2 root 2 times 2 root 2 is actually 4 root 4. Well, what is root 4? That's 2 times the 4 is 8, and then negative and positive make a negative. So it's x squared minus 8. So that's a quick way of doing it. All right, x squared minus 8 times that trinomial of x squared plus 10x plus 8. Again, do your box, 2 by 3 box, and then hit play, see what you get. And what you get is p of x, or again f of x, doesn't really matter, is equal to x to the 4. Where did I get x to the 4? I have 1, 2, and then 3, 4. Remember, it is 2 means I have 2 of them. So I have 4 x's, so I need the x to the 4. Plus 10x to the 3 plus 17x squared minus 80x minus 200. So there is your answer to example number 10. Okay? This will conclude your 4.3 video. This is how you do it. All right? If you have any questions, please ask. But remember, take notes, do work, be successful.